In this lesson, we're going to take a look at rational expressions. We're going to learn how to simplify, multiply, and divide rational expressions. And what those are a quotient of two polynomials. Quotient, remember, means division. Polynomials are what we studied in chapter 6. Alright, so the first thing we're going to take a look at is how to simplify polynomials. So we have a fraction, we always give our fractions in simplest form. So our first step would be to factor everything. Factor your numerator, factor your denominator as much as you possibly can. Get it into simplest factored form. So looking at part A, my numerator, 3x plus 4. I don't see a GCF. It's a binomial, but it's not a difference of squares or a sum of cubes. So that is factored. The denominator, we have quadratic trinomial. Lead coefficient's not 1, so I'm going to use the AC method. Remember, when we factor using the AC method, we have to factor by grouping. So first, we multiply our 3 times 4 and think what multiplies to negative 12 and adds to our b term, which is 1. So we have 4 and negative 3. So we rewrite that middle term as a positive 4x minus 3x. And then we factor by grouping. So my first two terms, we have an x as a common factor. And my second two terms, we have a negative 1 as a common factor. So now we have 3x plus 4 as a common factor, with x minus 1, that's my parenthesis, left over. So, going over here, this expression is 3x plus 4 over 3x plus 4, x minus 1. So, cancel common factors, and then we have it in simplest form. The other steps, now actually let me back up. Careful with this, when you cancel your 3x plus 4, your x minus 1 is in the denominator. Don't make that mistake of canceling everything and getting rid of the fraction bar. You can do that if everything in the denominator cancels. You cannot do that if your factor left is in the denominator. So it's 1 over x minus 1. Think about if we were simplifying something like 4/8. Well, they have a common factor of 4. When you divide the 4 out, the answer is not 2. It is, of course, 1 over 2. Same process when we're simplifying rational expressions. All right, so that's the simplifying part. The second part is identifying values of x for which the expression is undefined. Remember, division by 0 is undefined, so we cannot have 0 in the denominator. So there are a couple of values of x that would make the denominator 0. First of all, if 3x plus 4 equals 0, because before we canceled it, that was part of our original denominator. So x cannot equal negative 4/3. Or, if x minus 1 were 0, x cannot equal 1. So this is what's called the restricted domain. All right, let's take a look at one more. Starting again by factoring all expressions in the numerator, we have a common factor of x. And in the denominator, we've got the t-chart, what multiplies to 6 and adds to negative 7. Now I'm seeing I almost have a common factor, except for in the numerator, the x is negative and the 6 is positive. So I'm actually going to go back to my numerator and factor out a negative x instead. So for those of you that might have a hard time following me, I'm going to rewrite this in standard form, and now I'm going to factor out a negative x. Now I've got a common factor, and I can get this a little bit more simple. Going back, looking at the restricted domain, looking at the factored form of the original denominator, making sure to use both terms, including the one that I canceled. X minus 6 cannot equal 0, so x cannot equal 6, and x minus 1 cannot equal 0, so x cannot equal 1.